This unreleased NES game, Wonderland Dizzy, has a bit of a problem. You have to talk to this character Denzel to complete the game, but... Now, watch what happens on emulator. No crash. Why can the emulator handle this, but not the console? I don't know. My goal, though, is to complete the game on console, and luckily you don't have to know every single nuance in order to fix that. What you will need, though, is a Game Genie, so let's begin. I've got two save states loaded on emulator, which look nearly identical. The difference is the first state is before I talk to Denzel here, and the second state is after. And this emulator FCEUX gives you a lot of debug tools, and one of the most useful is the hex editor. And the hex editor actually lets you watch all of the game's RAM values in real time. Now this is kind of daunting because all these values are changing and we don't know what any of them mean. Now somewhere, one of these values in here keeps track of whether you've already talked to Denzel or not, and we gotta find that value. So maybe if I just flip between the two save states, I'll be able to see the different values. I mean, look at that right there. I see stuff changing all over the place. The problem is, despite these situations looking pretty similar to each other, there's so many values that change. So another useful tool is the RAM search. And the RAM search lets you search for RAM with specific values, or you can check to see, the number of changes that something makes. I think it preserves the change count between the different save states. So perhaps what we could do is we could swap back and forth and count the number of times that we do so, and then look for that in the number of changes. So let's clear the change count, and then let's go 1, 2, 3, 9, 10, 11, 12, 13. Now let's search for something with 13 changes. Okay, we have a bunch of addresses. Huh. Well, perhaps we've narrowed it down some, maybe. Now, did any of these look like a logical value? I think you can then search again. So I want to look for something where the previous value is not equal to the current value. And I'm going to search again. Nothing. Okay, so now it's paused. So now the previous value should be different from the last value. Hit search, and we have nothing. What? But we can try doing the brute force method. So why not just copy a large portion of RAM, then go over, change it to state 1, and paste it. And I broke it. Let's take less data so that it doesn't break, maybe. And paste it. And we still... okay, we're breaking it. Whatever, okay, maybe I'll just not touch those top values, okay? Okay, I just keep crash. How do I select all? Alright, you know what? Copy the entire RAM state. It's got to be somewhere in here. Oh my god, I hate my mouse. It is the slowest thing. Let's just copy every single piece of RAM. Go to save state number 1. Paste. How does that break it? Should they not be identical? I copied every piece of RAM. That doesn't... how does that... Right, you'd think it would have to be one of these. And there's only 88 possibilities here. So what if we click watch on this? Okay, so now we're watching this RAM value. It would be really nice if I could just freeze all of these values. Okay, that's good enough for now, maybe. So this is at address 0039. So if we go into row 0030, and then count 0, 1, 2, 3, 9, yeah, here's our value. So now it's highlighted. Okay, yeah, 003C. That's right next to it, and we can try and bookmarking that one too. So let's just watch those 4 values maybe at first. So maybe it's one of these. It's not any of these. Remove all bookmarks, unfreeze all, and then get rid of these first 4 values because they are not what we're looking for. Perhaps we're going about this in a kind of inefficient way. It wouldn't likely be any of those values because it should be a logical value between the two of them. Okay, so look at 0098. That's switching between 0 and 1, because that seems like a very logical thing to be happening. Maybe if we just go and freeze this, and then go back to our first save state and then go talk to him. Did that work? Was it that easy? Alright, so I guess the answer is 0098. While we found our value, we still need to be able to create a Game Genie code in order to fix this on console. And knowing that is not enough. So what I'm going to do is I'm going to right click here and I'm going to add a write breakpoint for this address. And so now it pops up with the debugger. So when I go and talk to Denzel, the game will freeze. And it did. And you'll see that before we even get to talking to him, it's writing to this address. Okay, so now we have to understand what's happening in assembly. Oh boy. The NES runs on 6502 assembly, which looks like this. Instead of variables, you have to save to RAM memory addresses, or to one of your 3 registers, X, Y, or A. You also don't have loop statements. Each line of code is numbered, and the program counter keeps track of your location. You'd have to make a loop manually by adding a branch statement, which based on the value in A, sends the program counter to a specific place. You can do functions, but in assembly, they're called subroutines. If you put in a JSR statement, or jump to subroutine, and give it an address, when it hits the RTS statement, or return from subroutine, it'll jump back to the JSR statement it came from. These statements, operations, are really only here for our own human convenience. The machine sees all the code as a series of bytes, each byte being 2 hexadecimal numbers. Each operation has a corresponding opcode, and operations take in a differing number of parameters. There might be 1, 2, or 0. Since nothing distinguishes the parameters from the opcodes, the machine has to track that, but it means if it jumps to the wrong address, say the location of a parameter instead of an opcode, you'll end up misaligned as the code will look like nonsense and the game will crash. And you can see in this example, on the right we're starting in one address higher than the left, and we end up getting a completely different set of assembly instructions, because it interprets the values as instructions and the instructions as values. The reason this matters is because we're going to edit memory addresses with the Game Genie. A Game Genie code consists of 4 bytes, 2 for the memory address, 1 for a comparator, and 1 for the new value we're going to use. If the last 4 digits of our program counter match the Game Genie's, it checks to then see if the value the machine is reading matches the Genie's comparator. If they match, it replaces the value instead with our new one. Here we changed a value, but we could change the jump opcode, or JMP, to a branch on equals statement, or BEQ, by setting the address to one earlier, the compare to jumps opcode, and the value to BEQs. Now, one hitch in doing Game Genie codes is that there can be more than one place that matches, so there could end up being unintended side effects in another spot in memory, but luckily the tools we're using will tell us if that happens. Alright, well, you know what we'll do is we'll just step over each line until we see the screen change, at which point we'll know that something went wrong. So let's step, 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 step. And so that's right there. We want to prevent this from happening, this JSR CDFE. What does JSR mean? Jump to subroutine. So what's going on at this point? 20 is the jump subroutine command, and then CDFE is the address. Let's see if everything functions normally if we change the program counter, which is at A31B, to the next line, which is A31E. Alright, and let's just run it now and see if the game still functions. And it looks like it worked. Now if we go and talk to Denzel again, we fixed our problem. Perhaps all we'd have to do with this case is just manage to jump over that line. If I'm in the Game Genie encoder enhancer right here, and I put in the address A31B, and I make the compare value be 20 because that's the command, it affects more than one ROM address. Now the problem with affecting other addresses is that it could mess up the game in other ways. Really, you'd want something that would only affect one address, so that way you know you're changing one thing and nothing else. Let's step into, maybe we could just make a return to subroutine. just immediately, once it goes in there, it leaves. So let's step, 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 step. Now pay attention to the return to subroutine. So let's step into, yeah, the code for return to subroutine is 60. If we find a line in here, maybe the first line that we do, we could change. So let's get out the Game Genie tool again. So let's look at address CDFE, because that's what we're on. And let's check to see if anything is ever 8D. And we only have one, and that should be our offset. That's probably the right spot. Maybe if we change it to 60, because the op code for RTS is 60. Maybe that would work. So let's try this cheat. Let's see if this functions. Now the issue is this might just prevent you from talking to anyone. Okay, yeah, it looks a little buggy with the way that it flashes, but let me just try talking to somebody else. Okay, yes, I broke it. There is no talking. Okay, so I can't do this, but we have a no talking code. Now it says branch not equal A321. So that would jump to A321. Does that happen on the other one? So maybe I can just change it here. So A308. And so what I think it's saying is, it's saying if this is not equal to 0, drop down this many lines. Maybe we could just change this to a BPL. Yeah, let's try changing it to the opcode for BPL, which is apparently 10. So let me just try 10. And we have another code. Let's see if this does what we want. And let's talk to Denzel here. And okay! It worked. If I go and talk to somebody else, no one may enter. Okay, we're still talking to other people. This looks like the code. APEXALEI. This side faces down? Like this? This is actually how you... Why would you put in the game upside down? Okay, whatever. I had it backwards. Who cares? It took about forever to figure out, but you know. There. Game Genie. And here you can see when I return to Denzel and talk to him again, his dialogue doesn't play, so the game doesn't crash. And as a result, I can now finish the game. Well, okay, I mean, unless you decided to go and pick up the cloth duster, and then try and pick up the lamp while holding it, because then you talk to a genie, and the genie also crashes. So, I repeated the whole process I just did, but now for the genie, and I found another code. I put that into my Nintendo, played through the game again to get back to that point, and now we can no longer talk to the genie, which means you can't get the extra life he gives you, but at least the game can't crash. Well, unless you play on the Polish or Portuguese version, where the game will crash on the second screen. Actually, each of the 6 or 7 languages crash the game in different locations.